test. Okay, good morning everyone, and welcome back to Mmusic. We'll be handing out blue sheets again. We have already one note taker. Thanks for volunteering, Keith. We would like to have another note taker. And Keith, for both note takers, if you can use the Etherpad. Okay. If the second note taker can I have someone volunteering? Excellent, thank you, Martin. And is it possible to use the Etherpad? Excellent, thank you. And Jonathan said he would volunteer to JavaScript again, so thank you guys for volunteering. As usual, Note 12 applies. You have seen it multiple times already this week. Our agenda for today, we had slight changes just yesterday there. We have now starting with the MSID, and we have happy eyeballs as the last item in the agenda. Sorry, dual stack fairness. It used to be known as happy eyeballs. Any comments on the agenda? Okay, in that case, Harald. Yeah, there's the box. Please try to stay inside that.
Think outside the box and present within it.
Yes.
Yeah. Okay, MSID. Next slide. I'm asking you to go back in time 3 years, revisit a decision, and make the opposite decision. So, document status of MSID, there has been no technical change to the actual mechanism for identifying media streams and media stream tracks proposed for a long time. And everyone seems to agree, after my discussions with Fleming, that that mechanism is stable and well described. But we have had a series of document reviews that critique the formulations going into which parts of this is the generic mechanism and which parts of this are the parts that are special for the WMS mechanism. And I've had so much trouble with this that I'm proposing some radical action. But since this is a working group decision that needs to be revisited, I'm taking it to the working group. Next slide. Just a recap of what it does. A media stream track is unidirectional flow of media. It goes from the sender to the receiver, and it has an ID value. A media stream is a collection of media stream tracks, all going in the same direction. When you map these things to SDP, one media stream track maps to one media section. In fact, when you're sending one media stream track in that direction and another media stream track in that direction, these can map to the same media section, which can cause some issues, but one media stream track maps uniquely to one media section. The MSID has two purposes. One is to carry the ID field as visible at the JavaScript interface for streams and tracks so that they're available to the other side. The other one is to, by virtue of having the same stream ID on multiple tracks, signal that these tracks belong to are members of the same stream. And that's all it does. It's a small mechanism for a very sharply defined purpose. Next slide. In Paris, March 2012, 3 years ago, I presented this to this very august body, and the decision at the time was Mmusic is the group that designs generic mechanisms that can be used for multiple purposes. You will redesign this to be a generic mechanism that can be used for multiple purposes, of which WMS is one. I've now spent 3 years trying to do that. So we have the MSID semantic field, which is a session level, SDP session level field. I always have to remember that SDP sessions are not RTP sessions, are not W3C sessions. Yeah, remember what a session is. Anyway, I got an MSID semantic field that tells you which semantics apply to MSIDs in this particular SDP description. And the only defined value is WAMS. There's been no proposals for a second user. Now, how do we tell which parts of the mechanism are generic and which parts are specific to the sole purpose? The answer is the only way to do it is by taste. You have to make an arbitrary choice because there is no second usage. Next slide. So I have 2 proposals in front of the group that I want the group to have to make a decision between. One is to fix what I have, address Fleming's comments, invent some guidance for the expert reviewer, which will be the expert reviewer has to figure out some criteria in some wrapping, and hope that we have got the split right for when a second purpose shows up. Next slide. Or we can reverse the decision of 3 years ago. I'd like to keep the MSID semantic field because it's a future-proofing mechanism. It allows you to revise the standard in a well-defined way if we ever need it. And it's been shown to be useful for one purpose in a document. We add words to say that how to check that nobody changed the rules, again, future-proofing. We integrate the sections on MSID and the generic, and we say more mechanisms can be added by updating this standard and no other way. Next slide. So, to sum this up, I think the MSID mechanism is well understood and documented. The split between generic and specific is not well understood and it's not well documented, but it does not affect the mechanism. So my proposal is that we close the box and move on. There is only one usage of this mechanism. And the last thing I want is to be back here in 3 years arguing about it again. Now, open for questions, comments.
Right. So, Martin Thompson, I think there's a couple of things I need to point out on this one. I perfectly approve of the Highlander approach to this. I would go much further than you, though. This whole MSID semantic attribute in our implementation, it's just a burden. It's baggage. And it turns out that interoperability is not great on that attribute anyway. So I would suggest simply cutting it from the spec. There's a whole lot less work to do maintaining that then for everyone involved. And
Yep, there's yeah.
I'm proposing that we cut A equal MSID semantic entirely and MSID means this WMS semantic that you've described. And
Thank
we
you.
all
So
understood.
the proposal is to cut MSID semantic. The only objection I have to that really is it turned out to be one single place where I needed some indication that although there are no media streams tracks attached to this SDP at the moment, I'm promising that if there ever is, it will have an MSID field. That's the only place I need it.
So
Technically need it.
I think the fact that this is an A equal MSID attribute is sufficient. And if you want to do something that is like MSID but for some other purpose.
No, sorry. The case is where I have not done any ad tracks yet,
Correct.
and I'm sending the offer. But I want to make the promise that if there is ever a track added, it will have MSID, so that when media comes in, which I don't have an M-line for, or which I cannot associate with anything with an MSID in it, I know that there's an error. It's in section 4 point, I forget which, in the draft, the one that says compatibility with old stuff. That's the only place where you need some marker that is not an MSID.
I'm going to need to look at that, and I'm not certain that we need to worry about that specific case. I mean, if you don't have any media, you can still,
Please read the section. It should be quick.
I'll read it now and make notes and get back to you.
Thank you.
Why did I volunteer to be a scribe again?
Because you didn't know you had an opinion.
Colin James. I support the idea of cutting this down to be absolutely as small and minimal as possible, right? So I certainly wouldn't want to go beyond just exactly the two semantics you explained, what you explained on your previous slides. I don't want any of the other extensibility stuff in. I think that just causes problems. Remember, new drafts can always define a new something else, right? And if in fact it's possible to go even simpler than you're suggesting, which it sounded like Martin was suggesting, I'd probably be in favor of that. But I definitely think that we should just get this down to not doing anything or containing any extra sort of fields to add semantic stuff later beyond just solving the minimal clear problem that you had on the previous slides. And I'm even willing to help edit.
Fleming Andreasen as individual. No doubt I was one of the people pushing for having a generic mechanism 3 years ago. I think, 3 years later, we have to look at, okay, were there any other use cases, right? How much is this actually a generic problem? And it's, looking at the spec right now, right, looking at the evolution that has taken place, it's just not clear to me at all that this is a very generic problem. So I'm definitely in favor of proposal number 2 as well. Simplify it.
Thank you.
John from Lennox. I think that I had some vague notions 3 years ago about what those generic mechanisms might be, and we've invented alternate mechanisms for all of those in the meantime. So +1 also.
Okay, so then question to the working group. It seems that there are not many other mechanisms around, so does anyone else have any other mechanism than the media stream track? Any other use case than the media stream track for this?
No. There is another issue that I'd like to bring up. I just want to insert that marker, that's all.
Okay, so for the note takers, we don't see anyone rushing to the mic with a new use case. Of course, still on the mailing list, if you have use cases for any other use case than this one, please let us know, but otherwise it seems we have only one.
John Lennox, also just to say, we're not precluding other use cases forever. We're just basically effectively changing it from expert review to standards action required, and not defining IANA table.
Yep. Okay, Martin.
This is probably a larger topic than you want to deal with here, but in the work that we've done on replacing tracks seamlessly in WebRTC, the identifiers change at the source, and that was found to be has some interesting repercussions for offer answer. Because what happens is you have a track, you replace it with another one, that other one has a different identifier, and you have to track the fact that you have the original identifier when creating a reoffer to avoid the surprise you have a new track on the remote side as a result of renegotiation. So the whole point of this replace track stuff was that we had something that was a substitute for the current one, and it would just seamlessly transition between one track and the other one. Turns out that has surprising secondary consequences unless you do some clever stuff.
Thank you.
I'm challenging whether or not we even need this at all. But
Sorry, Martin, just to be clear, so are you making any suggestions here, or this is just an observation? I mean, is this something that's an issue for the current spec?
Maybe, Justin Uberti. So I have had the same sort of concerns. I'm glad that we're simplifying this because I think that helps us kind of reason about this more easily. But I do think that, I think the point Martin was getting at is that you have track A plugged in, now you do replace track with B, and the remote side doesn't see any difference. And I think really the way that the remote side sort of understands these things is like it's got this MID. And that's the thing that's constant even when like the track changes, and that might be like more closer to the handle that we actually want to be using here. I guess the other point you're making is that when you do the replace track, the remote side doesn't see any change, but now after you do a renegotiate, they're going to see B instead of A. So like the sender needs to keep track of what was the original sort of MSID, which is now sort of isomorphic with the MID.
Yeah. So that's actually an excellent argument for the MSID and MID not being isomorphic, because you might be in cases where you want to change one and not the other. But I would like to take that discussion around the replace track.
We can do that, but I think it has repercussions for offer answer and SDP processing. The discussion that we had around this, we sort of concluded that this was okay when you do the replacement. You do the replacement, it's all seamless, and then you get the reoffer, and then you've got a new set of identifiers. What that causes on the remote side is them to notice that they have a new identifier for this particular media section. And what our code was doing was going, someone has replaced the track. This is a new track and stream. And we were basically marking the old one as closed and making a new one.
Yeah. So that this goes into the semantics of replace track. I told you I told you that when we discussed it at TPAC that this is harder than what you have presented, and I'm looking forward to seeing your proposal on replace track. I haven't seen it yet.
You have.
Not on the mailing list.
Yes, there is one. There's a pull request, in fact. Not mine. But to continue the story, when you see this new one, we concluded that when the SSRC remained the same, we would consider that to be a replaced track.
Yeah, so I guess what I'm trying to figure out is under what
names, please.
Oh, sorry, Eric Pasquarella. Under what situation? So I understand why I might wish to refer to logical tracks, hence MID. But I'm trying to understand under what situation does the SDP need to carry the information at which a JavaScript object is plugged into this particular logical slot at all? Like, can someone tell me what application would need that?
Well, I'll give you an example.
Okay, that'd be good to know. Okay.
So, Justin Uberti. So the reason we've had this is that you offer two video streams, and like the remote side needs to know which one goes into the left video tag, which one goes into the right video tag. So, yeah.
That's not the logical.
Yeah. Okay. So, you can say this is MID because MID is sort of like the container that carries these sort of things. And so I think what we're sort of converging on is either that MID equals MSID and we don't need it at all, or that sort of MSID uniquely identifies an RTP sender, in that like if I have an RTP sender and you just change the track, the MSID stays the same. But if you then remove that sender and then add it again later, you get a new MSID. And so, you know, right. So I mean that because MIDs kind of like are constant for all time because you can't remove M sections and all that sort of stuff. So like MSID just may have slightly different semantics where it's not really coupled with the track, but it's coupled with the sender. I think that, you know, we're sort of designing this at the mic, so I don't really think that we can really figure this all out exactly here, but I think that the proposal to simplify this is definitely, like, we should keep going in that direction. We may be able to even further simplify it.
So,
What Dan said, I might give them
so I'm looking forward to having that discussion. I think parts of it actually belong on the public WebRTC mailing list because replace track needs to be discussed there. And I have lots of opinions, by the way, but I'd like to have a bit of separation of concerns.
I mean, +1 to removing semantic and then trying to see how much further we can chop this down to like a bite-sized thing.
Peter Thatcher, I was going to say effectively what they were saying about we could probably get away with just having MID. But the only issue I was thinking of was if we still wanted to have an identifier for the media stream, not the media stream track. Sorry, I'm also of the opinion that we can probably get away with just having MID and not having MSID at all. But we can further that discussion.
Just wanted to reply to Peter there. I mean, I agree we need that information, but in the same way that you could use something else for the lip sync group name. I mean, there's other given that's a lip sync group, that's information is also duplicated somewhere. So we might consider that at the same time.
I mean, the salient point here is that like MSID was invented before we had talked about lip sync groups and before we had talked about RTP senders. And so like we should now sort of reevaluate this in the context of what we know.
Okay, so it seems that clearly we want to simplify the system, as no one seems to disagree on that. But the details, well, we have to take it on the list. Harald, will you be driving the discussion on what exactly is then done?
So my takeaway from the discussion is, of the alternatives presented here, we're taking option 2. We're merging the merging the one.
Relaying parental Jessup.
Yep.
MSID approximately equals RTP sender seems reasonable. Not sure about MID versus MSID yet. It's parental Jessup.
Yep.
Sorry about
So continuing the summary, we have a further discussion about back to the 2 slide, proposal 2, that one. We have a further discussion that needs to be had about MSID semantic. I'm looking forward to suggestions for solving the one problem that it still solves in the spec. I'll produce a collapsed draft and present that to the group. And with my W3C hat on, I'll note that we have an action item to clarify what replace track means, and that if this has protocol implications, we'll discuss this with the chairs of the RTC web group. Is that a fair summary?
I thought I heard one additional thing, which is that some people are not sure we even need MSIT at this point. Is that correct?
Thompson, I'm not sure that I would go that far at this point.
I'm sorry, can you speak up?
I would not go that far at this point.
Okay.
There are other things that are duplicative of what we have here, but it's not clear to me that we actually can completely drop this. If we want to do the sort of things that the W3C has asked us to do.
Okay, thanks.
That might change.
Right. I'm deferring judgment until I see a exact clear problem statement of what this is supposed to do once you've removed all the other things we don't want it to do.
Right, and I heard that people were going to look at the list and come up with concrete proposals to see whether we could, how much we what was the minimum we needed? And Martin, I took you to say that we could get rid of all of this altogether possibly, and we should investigate that. If not, I think that we should look at the overall. I mean, look, anytime we have duplicated information, we know it always causes problems. So let's have as few identifiers as we can get away with. That's what everyone's going to agree on that. And no one really knows whether we can or not. And Harold suggested that happened on RTC Web mailing list. Is that
For what information needs to be transferred,
Yep.
I mean, this started out with an assumption in WTC that the ID of a track on one side of the connection has the same value as the ID of the track on the other side of the connection.
Okay. I don't think anyone's changing that assumption. We know the requirements at that level, right?
Yep. And the protocol mechanics of carrying those IDs at the same, carrying those IDs in SDP are an IETF matter.
Right. So the question we need to answer is, how do we do that in SDP, right? Do we need how many fields, new fields do we need? What do we need? And no one's really quite exactly sure right now, right?
Yeah.
Is that
Yep.
fair summary?
And I have lots of opinions and will share them on RTC Web.
So I think just maybe I'm happy to have this discussion on the WebRTC mailing list, but it'd be nice to be precise. And when you say the ID on one side should be the same on the other, is the ID referring to the logical ID or the ID in the media stream track? Because they're not. Because the whole point is those are different things, right? So I'm happy to. So I mean, I'm happy to defer that discussion to the mailing list, but that's the thing we need to get precision on.
Yeah. I'm referring specifically to DOM string that is visible as an attribute of the object in the DOM model.
In the media stream track object.
In the media stream and a media stream track.
Right. So I think actually I am no longer convinced we need that based on new information. Again, happy to do this.
We will continue the discussion on the WebRTC mailing list in relation to replace track. That may have repercussions for other mailing lists, depending on what the conclusion is. WebRTC, public WebRTC at w3.org.
Okay, I think we have a decision on the parts that relate to Mmusic. Thank you.
Yeah, and the only other point I would want to make was that we were trying to drive towards working group last call. That was the idea. It doesn't sound like, even with the simplifications, that we're going to be there right now. But having said that, also I'll note that with the scope that we are essentially agreeing on at this point, the only customer for this is RTC Web, right? So we will wait for RTC Web to basically tell us when they're ready and they feel that they truly understand what is needed here, and then that will get reflected in the spec. Does that sound right?
Okay, RTC Web chairs, do you agree to take on this mission?
RTC Web chairs or WebRTC chairs?
RTC Web chairs. RTC Web chairs.
Sure. It's all good. There's nothing we can do to stop it, even if we didn't want. No, look. Obviously, we're getting close to finishing the system. We're realizing that some of our initial assumptions may just need a little jiggling. We need to refresh, work through those at all three working group levels, right? And nail this down. But I think we're close. But I think we're going to need a significant revision of this draft and major simplification. I'm glad it's a major simplification, not a major addition, before we're ready for working group last calls.
Okay.
From Jabber, Paul Kisvet says maybe move the draft from Mmusic to RTC Web. Well, can't. Well, I mean,
This draft's about how you carry some data in SDP. Whether there's a need for this draft or whether other things can be used, maybe will be discussed somewhere else. But this draft is very much deserves to be an Mmusic, right? I mean, it's extending SDP. I definitely want to fob this on you guys.
But
I actually quite liked Paul's proposal, I have to say.
I mean, to be clear, that was back when we thought this had generic applications. And if this doesn't have generic applications, maybe it does deserve to be an RTC Web.
Speaking as the other chair who was standing behind him in line, going, yes, yes, keep it with them. This is Ted Hardy speaking. I'm standing to support my co-chair Cullen in his statement this needs to stay in Mmusic, primarily because
whenever you're extending these things, it may have an implication on the rest of the SDP system, and that's why we keep all of this work here. Even if there's a use case specific to RDC Web, this is the place we have to fix this.
John Lennox, really for Paul, he says, we allow other working groups to define attributes. It happens all the time. And speaking for myself, this is why we have an SDP directorate, because we let other people define attributes.
Just anybody, was there an editorial stance expressed there?
Yeah, I think we have the draft right now. We'll keep it here for now. We can discuss further offline, including with our AT, if there's a strong feeling that we should move it out of this group.
Well,
The
we
chairs
need the
will not
work, and
object to that.
this is Ted again. If we need the work done, right? So if the Mmusic group decides it's not going to do the work, then yes, of course, we would take it back. I think, however, up to this point, we've assumed it's in Mmusic, the work has gone on in Mmusic, the context is in Mmusic, and I hate restarting the context somewhere else.
Yeah. No, I agree. And we have a milestone and everything. So
I mean, spending time on deciding where the draft goes instead of actually getting the draft right, I would not like that. Okay, are we finished?
Since you mentioned AD, your AD in general agrees with what Ted said.
thank you.
Okay, and then a final note. So this discussion will happen in WebRTC. Is that correct?
Define this.
Okay, I mean, the discussion on the simplification details. So, and then, well, okay, but wherever it then occurs, after you have reached a conclusion, can you please summarize also on Mmusic? Excellent. Thank you. So next we have simulcast.
Okay, hi, Mozinati, on behalf of Bo Berman, Magnus Westerlund, and Suhas Nandakumar. This is the first version of the working group draft for simulcast. Next slide, please. There was an IPR disclosure that the chairs forwarded to the list. Just reiterating it here in case there's any concerns about this work. Next slide, please. So reviewing what the common use case for simulcast is, typically in a switching mixer environment where you have an RTP switch that is not transcoding media, but is just switching the RTP streams. You could imagine if you have several participants and they want more than just the active speaker to be switched in, if they also potentially want a thumbnail strip at the bottom of the screen, then in order to achieve that, each participant can simulcast both a high definition resolution and a thumbnail resolution up to the mixer. So those are all the up arrows, big A, HD, little a, thumbnails. And then the mixer can flexibly decide which high def stream should go to which user and which collection of low def streams can go to the other users. Next slide, please. So reviewing the SDP, the main point is that this is expressing concurrency. You're sending multiple RTP streams from the same sender, from the same media source, to a peer, typically up to a mixer. And the current SDP is a semicolon separated list of payload types. And this is a key point that we're using payload type to specify the different encodings. And we'll talk a little bit more about that. So here's an example in what we just saw in the previous diagram. This would be a simulcast offer to send both the HD and the thumbnail, but receive only the HD resolution. So this would be the endpoint or the participant's view. It can send simulcast, but it doesn't necessarily want to receive a simulcast. Next slide, please. So the open issues that we have right now, so there's some concerns about the terminology, and the authors had a discussion, and we agree that it could align better with taxonomy to make some of the concepts clear. Go ahead, Ronnie.
Ronnie, can you go back one
Yeah,
slide?
sure.
In this case, what will happen if the receiver doesn't understand the AC mulcast line? he will probably be able to send any one of them, right? That's what.
Right. So
Not just one of them, but it's not which one. Preferably 96.
Right, so it's a negotiated attribute, so if it's not echoed in the answer, then there'll be no simulcast present, and existing offer answer rules for the payload types that were declared govern. Only one stream in that case, only one concurrent RTP stream in that case.
So I think there should be some guideline about the ordering of those ones that will make sense of what really you want to get if you are not, if the other side doesn't support simulcast.
The ordering of what?
Of the payload type numbering inside the M line, because that defines the priority.
On the M line itself? On the M line itself?
And the M line itself, because
that's just regular SDP. We don't specify anything about what happens if you don't negotiate simulcast. It's just regular SDP rules. We don't reiterate any.
That would be HD. That's what will happen.
I mean, it's just like SDP. You have a selection. You could send HD or SD, either one. Yes.
So.
Yes, preferred. Right.
Martin Thompson, I have two comments. One, I'm a little concerned there's a bug here. So in your example, you have two payload types, one for big, one for small, ostensibly. Someone who's not aware of which one of these, not aware of the simulcast stuff,
okay.
Could choose to send an offerer 97. And you've just marked in your simulcast line that you don't want to receive 97. So this means that anyone who generates an offer in this form has to be prepared to receive stuff that they wouldn't ordinarily receive. That's covered in the draft?
It's not covered in the draft, but it's covered by the fact that you have to have an SDP which is backwards compatible with what you want, what your operating point would be without simulcast.
Right.
So this is for brevity. You'll see if you look at the backup slides, there's a longer full offer that would show what payload types you would offer, and any of those could be selected for your non-simulcast mode of operation. And on your simulcast line, you only pick the ones that you want if they negotiate simulcast.
Right. And so the observation here is that there are other attributes that an answerer might see and understand that will cause it to choose ones that the simulcast line has effectively caused to remove. But you will only get one in that case, which is, I guess, the only sort of consolation in that.
Yeah, I mean, let's go back up to the very first bullet. The key point about simulcast, and thanks for Christian for pointing it out on the list, is concurrency. The key point is that this is listing the number of streams that you want to send concurrently. You have to be able to send or receive any of those streams individually, but simulcast expressing what combination do you want to send concurrently. So if there's a stream that you don't want, period, then you wouldn't even have it in your SDP, right? This is only expressing which ones do you want concurrently in send and receive directions.
Relaying for Paul Kisvet says there's potential confusion with using PT to distinguish sent streams because the receiver may receive them in a different PT because of non-symmetric payload types.
Yeah, that was brought up in the Honolulu meeting, and we clarified that in the draft it says that too, that it's the regular semantics. The payload type between the two sides can differ, and you have to do the usual payload type matching of the media format itself, not just the number. It's no different than any other attribute that uses a payload type in SDP.
Yeah, so can you double check that excellent explanation you gave just now is actually in the document?
I think Bo can confirm that it is, right?
It is? Okay.
We had discussion about that.
All right. Yep. Oh, sorry, the second comment was that that grammar is rather irregular in the sense that your send is delineated, the delineation is a semicolon, and 97 in that list doesn't have any qualifier, so if you are delineating on space then semicolon or semicolon then space, you get different.
Yeah, we're happy to suggest any other syntax. So the basic point is that the semicolon separated list of payload types. We list all the payload types of concurrent streams, and the semicolon separates all the concurrent streams. And the direction is a prefix that tells you all these concurrent streams are in this direction. And then you can have another direction with a list of concurrent streams. but
There's just an extra semicolon here? Is that what we're talking about?
no. Oh, that's what you mean. Okay.
All right, okay.
Yeah, that could be eliminated. I'm not actually sure what the BNF says right now. Yeah, we can tweak that. Okay, is everyone clear on what was decided in Honolulu now? Okay, next slide, please. So the first open issue was to clarify the terminology, to emphasize the point of concurrency, that simulcast is expressing concurrency. We called it simulcast versions. It's probably a bad word. We need to find something better to describe that and align better with the taxonomy. These are really multiple concurrent source RTP streams, and we won't use that full blob, but we'll figure out a good way to wordsmith that. And there was also some confusion about the alternatives. I didn't show that on the previous slide, but you can, just like in regular STP, you can have a list of alternative payload types that can dynamically switch in for this RTP stream. There's also a list of alternatives that you can put in the simulcast line separated by commas, and that's why we have the semicolon separator to make it a distinction between the concurrent streams, which are separated by semicolons, and the alternatives within each stream, which are separated by commas. So we'll clarify that those alternatives are just the same as payload type alternatives in any STP offer or answer. And again, this is for dynamic switching, not for concurrent transmission. Next open issue is to be able to pause streams initially, and we'll have a slide on that, a couple of slides on that afterwards. And then finally, a little bit thornier, some issues came up around signaling bandwidths, signaling FEC repair associations, and a recent proposal for another ID that may relate to simulcast. Next slide, please. Okay, so pause streams. In the current draft, there's only a note about the possibility of introducing pause support. And after some more discussion, we feel that this would be valuable. So the plan is to, if there's no objections, to add the ability to pause a stream initially from the SDP. And this is basically the same thing as if you had sent an RTCP pause or TMMBR at the beginning of the session, but to avoid a race condition with having to wait for the high rate media to come in to be able to pause it. Colin?
So Colin, just to make sure I understand, so this is different than send only, like I'm thinking about how this interacts with how we put a call on hold, right? So this is going to be different because it's going to be undone by the RTCP mechanism?
Exactly. So the point is that we don't want any more signaling. Once you establish this STP, there's no more STP signaling. This is not inactive or send only or receive only. This is the RTCP pause or timber semantics, that it's only media level squelch, and it may come back right away at media level, and no STP exchanges.
I mean, it makes sense. It'd be exciting to also use a similar mechanism for like sending the initial compression codec across over SDP or something. Like, I mean, this opens up a whole wide range of ideas in SDP. But I think I'm in favor of it.
Can you go next slide, please? You can show the actual. Sorry, it's a wall of text. I'll try to summarize it.
Jonathan Lennox, how do you ever unpause if you've never gotten any media and don't know the SSRC?
So the very last line there, so the paused sender, if this is negotiated, the paused sender must send the paused message, the acknowledgement of pause, or TMBN 0.
Have you got more than one simulcast that's paused? How do you know which one's which?
All of these have SSRCs.
I understand. You don't know the payload type in the RTCP.
Yeah, that is an issue. That we need to look at for the pause streams, do you have the right information to be able to answer the pause in RTCP? And so the flip side of that is that if you don't have this mechanism, then you cannot pause the stream until you get the media, because you don't know the semantics of the pause, and timber messages, you have to timber or pause a specific SSRC, and you don't even know the SSRC until the media starts coming in. So that was kind of the motivation for needing this, to avoid the onslaught of media before you could do the pause.
So, Magnus Westlund, I think now deciding at the mic, so to say, I think one way of getting out of this is actually to include information about the rather binding towards something which is RTP source, stream identification, and then binding the simulcast cases to that might actually get us around that, because then you include that in RTCP, the actual identifier, and then you would know which streams it would relate to. So, but yeah, well, look, and we have to design something for this and look at it. So.
Yep. Okay, so next slide, please. So that's just the example of just put a pause indicator at the end of the stream that you want to pause. Next slide, please. Okay, so the other major open issue is people brought up the ability to simulcast different bandwidths, and there's a notable lack of the ability to express different bandwidths per payload type for VP8, and I assume VP9, but there's still time to get that done. So in the simulcast case, you would need a payload type binding. There could be a new bandwidth attribute that binds the different bandwidths to specific payload types, and there actually is an expired draft that did propose something like that. The alternative is also something else that was presented recently, an encoded stream ID or RTP stream ID. So we'll probably have some list discussion about that. That's what Magnus was alluding to. And the similar issues exist for FEC bindings. If you have a repair flow, do you associate it with payload type bindings, which is what retransmission does, or do you need something else to bind it, something like this RTP source RTP stream ID? Go ahead, Harold.
Just a question. What do you mean by bandwidth per payload type? I was trying to find the bandwidth in the examples and I couldn't find it.
Lack of bandwidth per payload type.
No, I mean, I was trying to find the bandwidth in the H.264 examples. I couldn't find it.
It's a rare case. You typically don't, for simulcast, you typically don't want to just send two different bandwidths with exact same resolutions and exact same.
No, I agree that it's useful, but I couldn't find an attribute on the examples for H.264 that specified the bandwidth. I found max Mbps, but as you know, compression makes that almost totally unrelated to bandwidth.
Right. H.264 has max BR, but there's no max BR in VP8, and so that's the issue we're highlighting here.
So H.264 has max BR.
BR, bit rate, yes. Yes.
Okay, so it's two ways of specifying for H.264. Thanks for teaching me that.
Sure.
Magnus Westlund, but yes, I do, as Harald pointed out on the mailing list, I do think we need to think about if we actually, is this really the right way of going forward, to overload everything on payload types? I know that things have happened when I was on leave, but yeah, I think we might need to have some reconsideration here.
And I'd encourage people to look at the backup slides if you can, because we actually have the examples of what would happen if there was another ID, not payload type bindings, but using some other ID that didn't depend on payload type. And we can have some better discussion on the list about that.
Ronnie Evan, on the bandwidth thing, if you use the bandwidth parameters inside the H.264, it's not the same as the bandwidth parameters in the SDP level because it doesn't reflect the same measurement. So,
but it does reflect what we want for simulcast. So we're not talking about channel capacity. The B equals attribute is for channel capacity. The max BR is really for this encoding. What is the what is the limit of this encoding?
Because it doesn't include even the RTP by itself. It's like it's not like TIS, which so it may make sense to be able to do something also in the SDP level, a generic one for that reason.
Right.
Colin James, I think that we do need like a consistent way to do this with all payloads going forward in the future, right? But it doesn't mean that it has to be it could be as a codec parameter, that all codec parameters defined going forward have,
And that's what was decided in payload a couple of IETFs ago. So the how-to document was
Okay.
logically the right place to put guidance about what for video formats, what should be expressed in a common way. There was a draft proposing to do a new attribute that would normalize all of that, but the feedback was, no, just put it for new formats, make them consistent about these common parameters.
Super, so that sounds like a great solution, and we're there.
Ronnie, just need to be clear what you are measuring when you're specifying this bandwidth in each level, because in the codec it's different than you're doing the RTP or
Yes,
you're
I
doing
agree.
the other.
Yeah. And most application developers have no idea what the differences between any of them are and don't care. Okay, so that's it. So that's the main open issue, is to figure out whether or not we want to stay with payload type bindings for all of the use cases, or if people want to propose some other ID to bind the simulcast, not just simulcast, but in general, to express a different encoding for the same payload type. Something that it would be relevant to simulcast, a different resolution, frame rate, bit rate, all those parameters. Do we need something beyond payload type to express those? So please give feedback on that. It's an important direction for this draft.
Okay, I guess we have to take that feedback on the list because we're running low on time. Okay, thanks, Mo. Okay, I will give next a quick overview of the status of the ICE-BIS work. And right after this one, there will be a couple of presentations which are very much related to this, so keep that in mind. Okay, next slide, please. So what happened since the previous version? We had a fix on the privacy addresses. This was issue brought up by Simon Perrault and also discussed on the mailing list. So basically the text that Simon was proposed with small edits was added to the ICE-BIS. And then also was another issue by Thomas Stach, was discussed also in the previous meetings, and Thomas sent the proposed text on the mailing list. No one seemed to disagree on that, so that is now part of the ICE SDP SIP draft. Next slide, please. One small issue that I've been struggling while doing the edits on the ICE-BIS draft is that there is still some RTP text. With splitting the SIP away, it went pretty well. Now SIP is used as an example of a signaling protocol that you may do things with. However, there is some RTP specific, for example, when it comes to component IDs, because as we discussed in the last meeting, the RTCP issue is pretty much probably the only one where you actually even need the multiple component IDs. So I would suggest that we actually keep those parts of the RTP, how it's specified use with ICE in the ICE-BIS draft. It doesn't say anything that you should use ICE, I should use RTP with ICE or anything like that. It's mostly just like, if you're using RTP, here's how you do it with ICE. I think that seems like a reasonable way forward. Okay, I see people nodding and no one is running for the microphone, so. Okay, we'll go with that. Next slide. Then there was some question at the last meeting, how about bundle? Since we have this formula for figuring out how quick you can do the checks, which will be also discussed more today, if you bundle your traffic, is there something special to take into consideration? So I had a look at the formula we use. The formula already sums your traffic across all your media streams. So, to the best of my knowledge, it doesn't then make a difference if we bundle them all in a single 5-tuple or not. Basically, the end result should be the same, because how the calculations work out, you sum your traffic across all the stream and then try to match your pacing to match the combination of all your traffic. So whether you bundle or not, that shouldn't be an issue here.
John, thanks. I agree with you that in terms of specification, there's no difference. I mean, obviously, in terms of actual practice, you'll converge a lot faster because you only have one media stream, which is why you bundled in the first place. But
yeah, but I mean, regarding the case where you are concerned that you will overload your link.
Yeah, no, I agree.
Yeah,
Yeah,
exactly.
absolutely.
Yeah. So this should be okay. Of course, if someone else has any other impact, so this was only specific regarding the pacing formula that I did the R&D. But if there's some other concerns, how ICE and bundle should interact or should not.
So Kalanjay, I mean, I think the most important thing about pacing has to do with the NATs start freaking out if you send them if you create new bindings too quickly. and then you get really unpredictable behavior. So, the basic, I think that's what really governs the pacing thing that we need to be clear of, is the global pacing, no matter how bundled, unbundled, really doesn't matter. The global pacing's got to be...
Yeah, it's basically, it's two issues. Definitely that, but the other one is overloading your own link, and that's why you would be actually dropping the connectivity checks and have false positives. It's both the issues are discussed in the 5245.
Yeah, so Martin Thompson, I think this is fine guidance to the extent that this limits the amount of data that we send in connectivity checks. However, I don't think it's the only thing that should be limiting the amount of data that we send in connectivity checks. I think we should just have a hard ceiling on this, otherwise we have issues with respect to malicious peers who might send us large bandwidth estimates.
Hard ceiling on what?
A hard ceiling on the rate or the number of bits, either one.
Okay, so you mean like the amount of bandwidth you would use on your connectivity checks? I guess that will be then governed by the whatever lower limit we set to the TA.
If you've got a bundled session with lots and lots of video described, and each one of the remote side sections says that they would like 5 megabits. Suggesting that stun doesn't use anything more than the 750 megabit that the session describes is not sufficient.
Okay, yes, I totally agree on that. I mean, this quote was additional, so you have the minimum will be, I mean, right now the minimum is 20 milliseconds. Probably want to keep that. But the rough guidance, if you have something above 20 milliseconds, you should aim something that stun would,
Yeah, I think, Jonathan, I mean, we already have the floor on the interval and the ceiling on the number of candidates. Yeah, so
yes.
I think this is more, if you're going to be doing something where you can calculate that would already be higher than the amount of bandwidth you're supposed to be using, go slower. This is a go slower if you're using really low bandwidths. That's the same thing.
Chris, just a side note. I mean, if we are worried about the bandwidth usage for stun, we need to remember that if you're using continuous consent, you're going to send this, as far as I remember, much more often. And I don't think there you don't have the option to slow down and things like that. I mean, you may have some, of course, but there is a time limit which you cannot go under, because then consent is going to expire.
But I guess continuous consent will always consume less bandwidth than the connectivity checks. It's less.
Why would they do that?
Yeah, because you send it like some seconds away. These are sent like every 20 milliseconds. So, and this is like instantaneous bandwidth. So of course, if it's a long session, you will end up sending long data with the continuous consent. But now we're talking about instantaneous bandwidth consumption. So when you do the connectivity check, you may send every 20 milliseconds, which is pretty fast compared to continuous consent. So I hope the continuous consent packets are not big ones. They're roughly about the same size as the connectivity checks.
Yeah, it means you're talking 4 times a minute versus 50 packets a second. So it's completely normal.
Okay, should be it. Okay. Okay, excellent. Next slide. And then there's been a lot of discussions on the mailing list recently on ICE details and virtual connections, and we will have a bigger presentation on that soon. However, what I would like you to pay attention to regarding ISPs is that what of those features or changes need to go to ISPs. I'd just like to remind you that what the ISPs work we are doing is supposed to be fixes and extension hooks. So what kind of extension hooks or fixes do we need in the ISPs in order for this to work? And then bigger things can be then documented in a different document. And the next slide. This is our long-running favorite, connectivity check pacing. So the TA value, how fast can you actually send the checks? We'll also have another presentation coming on this latest information. Justin will share some details. Based on the anecdotal evidence that I've been managed to gather recently is that, for example, Chrome has been used the 50 millisecond interval, doesn't seem to cause problems. Also, Paul Eric from Cisco is saying that on 20 to 50 milliseconds seems to work in all the cases they have been experimenting with. And also, Emil from Jitsi was saying that basically using the same low value for non-RTP traffic as the RTP traffic doesn't seem to be breaking anything. So at least all the anecdotal evidence seems to point to direction things don't break, even if we go to the 20 to 50 millisecond range, and I haven't heard anything so far otherwise. However, of course, we did agree that we will base our decision based on measurements, and we'll have more data on that soon.
Yeah, I mean, I think clearly, the problem, I'm sure all the people who are doing this testing are on decent first world networks. I'd be curious to see what happens, if you haul your old 28.8 modem out of the back of your closet and try to do it over that, how does it work? Because that's probably equivalent to what you're going to see in the third
Yeah,
world.
next presentation is going to be about that.
Okay, I just wanted to clear, the examples you all gave where 50 milliseconds seemed to work, and then you came to the conclusion that 20 milliseconds to 50 milliseconds. I want to be very careful on.
Yes.
I'm not arguing with any of the numbers. I worry people will read this slide and decide that 20 millisecond works, or
yes,
which is it?
I totally agree. So yeah, there is a big difference between 20 and 50, and that's in the next presentation we will have more details on how we'll figure out what is the right number for us. And then this last slide. Yes, we're getting there. Sometime soon, someone besides me needs to read the whole document. I know a lot of you guys are working on this, and this actually impacts your work. So I would like to get a few volunteers. Once we get settled down on the remaining issues, hopefully before Prague, and then someone needs to read the whole document from the beginning to the end. So I see Justin on the mic, so I guess you're volunteering.
Sort of, but I did want to bring up one point before I forgot about a discussion happened in TRAM yesterday, where there's a discussion about being able to basically signal what message integrity hash algorithms should be able to be used, and that's something that we should be taking considering for IceBIS.
Okay, so is that kind of crypto agility?
Exactly, hash agility stuff.
Okay. Okay, we'll have to have a look at that. I guess note takers have it on the notes. Has agility for the checks.
Yeah, it's being done, hash agility is being done in StunBIS, but it was identified that in order to avoid sending excess traffic, we probably need to have a way to negotiate this in SDPs.
Okay.
There was another thing.
Hello.
So there was another thing that we were thinking of putting into there. I already said it, Emil. Deprecating aggressive nomination.
Yes, that will be next. As I said, there's this part of the whole virtual.
No, because you're saying we're sort of almost done. Any volunteers to review?
Yeah, as I said, once we clear the issues that we discussed today. So yeah, deprecating aggressive nomination is one of those issues. And then once we're done with those, so this is I know it's an early request, but I know.
Yeah, it is.
But there's a lot of things. It's even though we cut away a lot of stuff, it's still a long document, and this deprecating aggressive.
That's about making it shorter, actually.
Yeah. so things we're not changing are going to be relatively small parts of that. But reading the whole thing, that it actually makes sense. That's what I'm looking for. So, Emil, I guess you are also. Can we take you as a volunteer to review? Excellent. Thank you. Anyone else? Okay, Paul, Eric. Okay, Emil, Ivo, Paul, Eric, and I guess Justin, kinda. Yes, Justin is nodding over there. So we'll do one more update, and then hopefully once we are clear on the issues we discussed today, let's start reviews. Okay, next slide. I think it's time for Justin.
Okay, so one of the things that we've sort of come to understand is that as we start gathering more and more candidates from multiple turn servers, from V46, we actually end up with quite a large number of pairs to check. And so, Chrome uses 50 milliseconds, but to checking 100 pairs at 20 packets or 20 checks per second, well, it takes 5 seconds. So how fast can we check these? Next slide. So here's the actual guidance as given by 5245, saying some tests were done and suggests a lower bound of 20 milliseconds of like basically how fast consumer net equipment can create new bindings. The exact sort of details and methodology of these tests have been kind of lost to the ages as far as I can tell. Next slide.
If you care, I'm the person who did it. I'm glad to let you know. But you know, they were flaky, poor, run experiments you'd expect from me.
Many of them are probably still in service, but yeah. Next slide. You know, binding creation is one concern. The other thing is just that what is the actual bandwidth that's consumed by this? These numbers are slightly off because I included the Ethernet header in these calculations. But basically, an ICE check is about 140 bytes, and you know, basically doing 50 checks a second, not even counting the responses, is 56 kilobit. And Chrome uses 50 milliseconds, 20 checks per second, to get to a rate of 22 kilobit. When the reason that was chosen back in the day was so it would actually work over a 28.8 modem.
Congratulations. So, Thompson, I've done these same calculations. The only thing that you'll note here is that the UFrag has a very big effect on this, but we've tied that down now, haven't we, in the biz? We're not allowing 256 character UFrags.
Yeah, sure. I mean, that prevents you from like really beating yourself up. I think that even if you went with the smallest at 4 character UFrags, you still would be, you know,
very little difference at that point.
Right, and plus if we're going to have like the larger message integrity with like SHA-256, we're going to give all of that right back. So
Let's just truncate that. But anyway, yeah, separate discussion.
that may be worth doing. Anyway, to make a long story short, I think we sort of historically treated, well, anything that's you know, under like sending uncompressed PCMU is probably fine. You know, anything less than 64 kilobit is probably fine. That does then imply that TA values less than 20 milliseconds, you know, could produce basically uncongestion controlled traffic greater than 64 kilobit. But you know, like I said, given the amount of pairs, this still may be desirable to do in certain cases, but we may not, you know, I think we need to get some guidance that if you're on an unknown network, you probably don't want to start just, even if we find out that TA can be less than 20, there'll be bandwidth considerations why you might not want to do this. Next slide. All right, so here's what we're going to do. Basically, we have a fairly decent install base of Chrome users, including many who are probably on 28.8 modems somewhere or something else. And so what we're going to do is basically find out for a very large sample of the internet, well, what is the lower bound for TA. And so basically, you know, try you know, doing stun binding checks, you know, spaced by you know, randomly, you know, see different users with different values of n of you know, how many milliseconds between checks. You know, do a control of basically sending all those checks to the same stun server, and then do the experiment of, you know, doing them to different stun servers or from different source ports. And as one might expect, the next slide, you know, the ones from the same socket to the same server will not create any new bindings. The ones from the same socket to different servers may create new bindings, and the ones from different source ports will necessarily create new bindings. And so we should see a very clear trend in the data of, you know, how the n value actually results in, you know, increased packet losses or delays due to this binding creation. So we are hoping we would have numbers for this here at IETF 92, but it turns out that, you know, there's no sort of experiment slide to binary code compiler just yet, and so this stuff is still sort of in making its way through code review. We expect to have results though before prog.
Right, so Martin Thompson, if you go back a slide, you've got the distribution of numbers. Is it too late to change that, make some suggestions?
Oh yeah, totally. I mean, if you have any, you know, suggestions on the methodology, this is why I wanted to present this here.
Yeah, so at 5, we're heading into the sort of territory where we're well beyond the send rate of the single PCMU that we've been using as a
absolutely, yes.
Right. So toward that end, I'm a little less concerned about it. It'd be really interesting to learn that 5 works.
Mm-hmm.
But I'd like to see a little more density around the sort of point where we are in that sort of bit rate, which is in the 16 millisecond, give or take, area, and probably less resolution in the set of numbers towards the upper end of this. I don't think there's going to be, I mean, this is all intuition, but I don't think there's going to be any real value in getting 4 values between 30 and 50. I don't think there's a lot of activity in that space.
Sure.
If anything, the behavior is going to be south of 20.
That's our expectation.
But you want to make sure you cover that a little bit above 20 and a little bit below.
Right, to make sure that our sort of view of the world actually is what we expect, because this is going to be a very comprehensive thing, and we may find out some interesting other dynamics.
Yeah, so maybe the suggestion is knock out 35 and 45 and put them in at 12 and a half and 17 and a half.
Okay. Someone just capture that for the notes.
Having sort of played with this, I'd suggest adding 100 as well. So Colin James, awesome experiment, and I'll send you comments on the list. I didn't realize you're doing this. It would be great to collect the data, at least at the aggregation level, of what country the IP address would say it was in, because that really lets you understand what sort of coverage you had on the experiment. And that makes a huge difference that we've found in sort of running similar experiments. And if at the server it was possible to record when you were doing, let's say, a 5 millisecond test, if on the stun server you could actually record the timing of how far apart those packets arrived, you'd probably see some interesting things about how the packets coming up to you are getting scheduled, which help explain why it does and doesn't work. So if it's possible to record that information, it'd be great information to have publicly available. And I'm phrasing this in a weird way because I can't release the data I have, but I wish I could.
So Martin Thompson, knowing something about the nature of these sorts of experiments, I believe that would be extremely difficult to do. And Justin might be able to confirm that, because you need correlation between the success and the rates.
I'll just sort of say, let's just say, like in your UFrags or something, you put like bit patterns that allowed your stun servers to identify which experiment this packet was coming from, and what the end value in the experiment was. Okay, this is not describing in any way what the success value was. It's just saying the packets coming out of the NAT, even though they were sent at 5 milliseconds at an application level, they arrived at the stun server with this type of timing between them. And you don't. The stun server's log back. There's information.
Yeah, if you could, perhaps we could discuss, kind of what you're looking for there, then we could sort of figure out what we could do to do this.
Okay. Argeran, I would also like to see 100 milliseconds there at the end. And then another thing, I hope you're doing some sort of publication out of this, so we have a stable reference.
Yep. So we intend to actually present this as a paper.
Okay, excellent.
At 4, do you create new sockets? Oh, sorry, Paul Martinson. Do you create new sockets on different interfaces, or the same interface, or?
We'll be picking. That's a good question. I think we'll just be picking things on the default interface, or on binding to the any interface.
Okay. I think we should do something about it, but we'll discuss later.
Okay. Yeah, I mean, but please send comments on this. We'll probably, the first set of things probably go at like this, perhaps with the timing values tweaked, and then as we get feedback, we can mess with this stuff. It's very easy to make changes.
John Lennox, just question: is this something you're just silently building into Chrome, or is this opt-in by the people who are doing the experiments?
It'll be something that sort of experiments run in Chrome all the time, and it'll be deployed to a fraction of the Chrome user base.
Okay, so there won't be any bias for people who.
Right. This is not a.
But it does mean that you're, if somebody who has Chrome on their phone doing international data roaming will all of a sudden have 64 kilobits of, have all this data being used for reasons they don't quite understand, and possibly paying, $1 a megabyte for it.
Only if you have. Only.
Okay, fair enough.
Okay. Okay, thank you, Justin, and we're looking forward to those results.
Okay, so this is talking about what we should be doing in ICE-BIS and perhaps further for improving nomination procedures. As I mentioned, there's, well, go to the next slide. We have, when we have a lot of pairs to check, sort of this desire to check those pairs very quickly and get media going as soon as possible. But B, one of the things that aggressive nomination has as a downside is that the controlling side can't make dynamic decisions. That it says very explicitly that the only way that you figure out what is your selected pair is the sort of the highest priority valid pair. And this is not always like what you want. For example, if you have multiple turn servers, you want to route through the best turn server based on RTT. You can't actually do this unless you have some a priori way of assigning the right priority to the turn server with the best RTT, but how do you even know? So there are actually a number of problems. Also, aggressive nomination and regular nomination, the fact they both exist, makes stuff more complicated, and ICE is quite complicated already, so there might be a nice opportunity to simplify this. So I think it's actually not necessary. Next slide. You can actually, based on the rules that exist within ICE right now, you can actually start sending media as soon as you have your first valid check, even with regular nomination. So if you look at this diagram here, we have Alice and Bob trying to communicate with one another. Alice has a host-only candidate, and Bob has host and relay candidates. And even though the check between Alice and Bob's host candidate fails, once the host relay check succeeds, Alice can start sending media. Then later, when the host candidate changes, or the host stun check succeeds, she can switch the media to going from the host candidate, and then at the end, she can say, well, okay, here this is the best candidate I think I can find. I'm now going to send a use candidate attribute, and media's already been going the entire time. The use candidate just sort of indicates, hey, now ICE has concluded, and the other side should snap to whatever whatever pair that the controlling side is now using. So I think there's ample sort of indication in 5245 that this can be done, that you can start sending media immediately, and basically you can get all the benefits of aggressive nomination with the control on the controlling side to say which pair is actually going to be used. Next slide. So, like I said, this is all described on page 69 of 5245. Thanks. What's that?
How could anyone possibly have missed it?
Yeah, exactly. Thanks to Dan Wing for basically having that factoid in his mind and being able to bring that to the list. We did consider the case of what happens if there are endpoints that are out there that refuse during regular nomination to receive any media, and just the worst case is that, well, you wouldn't get any media until nomination completes, which is the same as what you would get with regular nomination anyway. So this sort of is sort of self-fixing in many ways.
So Colin, I didn't realize this. I think most people who implemented this did not believe this. They believed that the difference between, actually, let me ask you a question. What is in traditional ICE that people implemented a while back? What was the difference between aggressive nomination and regular nomination? I think most people thought it was that they couldn't send media until they were finished the ICE process with regular nomination.
I think that's probably true, and I think that in many implementations, they don't send media until the process completes, but it's much less clear about whether they can receive media before this completes. And in fact, the Chrome implementation, when doing regular nomination, will receive media properly, even if someone starts sending it prior to a nomination completing.
Right. Okay. Well, I guess the thing is that it seems the important one we want is aggressive nomination. That was the one that most people implemented and used, and we want to make sure it keeps working and works in a backwards compatible way with whatever we do in biz, right?
Sure. Although, already things that are using aggressive nomination, since aggressive nomination must not be used when unknown ICE option is found, need to be able to fall back to regular nomination anyway. So I think this is backwards.
So that was widely non-implemented.
I concur. But.
Yeah.
But like for isolate, you have to support regular nomination anyway. So I do think that most of these things probably do support regular nomination if they support isolate.
Yeah. So Martin Thompson, I know that there are some implementations that will work by accident with this. I know that Firefox doesn't. It will not send the client handshake or server handshake messages until such time as it's seen an ICE resolve in one way or other. Of course, always does aggressive nomination, ignoring the ICE options, as far as I'm aware as well. But however, I missed this section when I was implementing this a while ago. How could that possibly happen? But it would have had the right behaviour. Well, it may be contradicted, but no, I couldn't find any contradictions when I went looking. But you know, you find a new thing every time you go looking in that document, I'm sure. So, but this has worked by accident for a number of people, and the consequence of it not working for someone is simply equivalent to packet loss.
Yeah, I mean, I guess I'm in favor of making this change, but to be clear, this will have inferior performance properties to aggressive nomination for non-conformant endpoints, right? So what's, as I understand it, the point of making this change is is an answer to the question of when is ICE resolved, right? And that now you can use candidate signals as an indication for that, right?
Well, use candidate was always the kind of indication of when does ICE resolve for regular nomination.
Right. So my point is this is the answer to this is the answer to the question of how do we deal with ICE resolving with aggressive nomination is don't do aggressive nomination, do regular nomination, and instead send without.
So you get three benefits out of this. You get you get to know when when nomination completes in all cases. Two, you get the case where you get full control on the controlling side because now that you can send explicitly, here's what I'm actually using. The controlled side can know what how it actually resolved. And thirdly, now it's going to be able to simplify this because you won't have to carry around the code to do aggressive.
Right. I mean, I agree with I agree with Martin's point that this certainly in kind of the spirit of 5245. Otherwise, why would you have a nomination? But I guess I don't necessarily see a problem. I mean, it seems like the alternatives are to do this or to say, well, we really only have aggressive, and then we're going to have a signal that says we're done. A second signal that says we're done, right? I mean,
really use candidate, yeah.
Yeah, really use candidate. I mean it, right? See, what is it?
But even if you had that, you still wouldn't have the ability to have dynamic control on the controlling side. I mean, unless So
Glenn, I want to think about this really carefully. I mean, this looks to me like you're describing as we're always doing regular nomination, but what this really looks like is we're always doing aggressive nomination in all implementations. And the case here that, it's no worse than regular nomination doesn't actually work in many cases. It takes so long to get to the point that you've done that the person hangs up before they've actually done it. So it's really bad for some use cases.
Okay, so I mean, I think there's a couple ways we could deal with that. I think it sort of fixes itself in many ways, and you have to do regular nomination with isolate, so everything has to do regular nomination, only sometimes. But one thing we could do is we could say
widely not implemented again.
all WebRTC stuff has to do isolate. But one. Sorry, go ahead. Well, the point I was going to make is we can mandate this for trickle. That all trickle-aware endpoints, have to be able to do this, and so we could sort of have a carve-out where if something doesn't support trickle but supports aggressive, you could still fall back and do aggressive nomination. So I think there's some ways to kind of be able to have our cake and eat it too.
Yeah. So I mean, Jonathan, I think what this really is, it's not so much that we're deprecating aggressive per se. It's that this is the behavior of aggressive with the wire format of regular, and that actually works. And so, by the way, I've decided I tried to convince people to call this passive aggressive nomination. So I probably that takes off.
Eric Pasquarella. So refresh my memory, but even if I'm a half trickle endpoint, that is, I'm a web browser basically, that's going to drive. That's supposed to drive me into. That'll drive me into regular nomination, at least in some cases, right?
Well, it's going to have to, just because the fact you're advertising this ICE options trickle, blah blah blah.
That's where I'm going with it.
Yeah,
Right?
yeah.
So I guess my point is that I worry about that. Well, I'm sensitive to Colin's point that regular nomination doesn't presently work very well, right? It seems like we've already bitten that bullet by having this this trickle option, because we just shoved ourselves in regular nomination. Now our task is to either, is to fix that, assuming, by the way, that anybody follows this rule about unknown us pretty aggressive. So I mean, maybe one question here that would help us think about this would be, do we understand what the state of the field of implementations is in terms of, like, if you're your average web browser and you conform with the spec, do you actually end up in aggressive or irregular most of the time, right? With other people.
With non-web browsers.
It doesn't matter.
Yeah.
Those are okay.
Okay, Ari Keränen, a couple of comments. Regarding this trickle ICE falling back to regular nomination, for that we had the proposal of the ICE options optional. But of course, if we do this, maybe we don't need to do that. Then there are some benefits on the regular nomination that it's depends how you implement your ICE stack. How I implemented it, that you run ICE and then you get a socket and then you do the thing. Yeah, and you don't expect to be swapping in between. If you do real-time application, maybe that's not the right best way to do it, but for some applications it makes a lot of sense. So, I mean, I think you want to keep still that behavior. And then...
So, sorry, you were saying that the ICE algorithm, basically, you do the ICE thing, and then you, at the end, when you're done, you vend the socket up to the higher layer?
Yeah.
Yeah, so, like, you wouldn't be able to get any media then until, like, okay.
Yeah, exactly. So probably not a good idea to do that on a real-time stack, but...
Yeah, I mean, you already have a problem. So, sorry, yeah, so, I mean, Jonathan, I actually don't see how that implementation works with, if you're the controlled endpoint and your peer is doing aggressive currently. Because you don't know what socket he's going to end up choosing.
Yeah, you don't do that.
No, it's not that you don't do aggressive. You have to make sure the guy you're talking to doesn't do aggressive when you're at the controlled endpoint. I don't know how you can verify, how you can ensure that, unless... Oh, ICE option. Yeah, I mean, the other thing about the trickle, I think the trickle thing is actually a red herring because, or at least for half trickle, because the controlled endpoint doesn't have any control here, right, by definition. So if the offerer sends a trickle, he's the controlling endpoint anyway, and the other side has to take what it gets. And I don't think you can respond with trickle if the offerer didn't send it. So.
Sure.
Ari Keränen, and then one more point. I remember earlier there was some worries about media clipping if we do something like this.
Right. So I mean, like the case that you would be concerned about here would be if you couldn't receive media until after regular nomination completes. Any media that was sent prior to that, would get discarded.
Yeah.
Now, like, I don't know if that's any different than like the regular nomination state anyway. Because any speech that occurs before regular nomination completes is going to be discarded. So it's not clear it really works out in any practical case to be any worse. I mean, I imagine like what we may end up just doing is just implementing this in Chrome and kind of seeing what happens. Does the world catch on fire or not?
It's one way to find out.
We're talking about change to ICE for devices that, like, it's not like Chrome goes and tests with most of the devices that the other implementations of ICE, right? So I'm not sure that that's a great way to drive to figure out the answer.
Well, we're not just to throw it over the wall. I guess I was being a little bit sort of abrupt there. But I mean, I think that is something we could sort of roll out and see what actually happens in terms of like, does anything actually malfunction when this occurs?
I mean, this Chrome certainly has had issues of not getting its connectivity as fast as we wish we could. So through the various icings, and that's what's driven trickle ICE and all these other optimizations we're doing. So it's obviously important for this to work and get media, to be able to get media flowing as early as possible has always been a clear goal of ICE. And I think that we need, as somebody said, who knows what the draft says. I agree. Every time I read this RFC, it's like the gift that keeps giving. Right? You find a new little gift for you. Yeah, exactly. Ouch. Pass it on to my boss. But I mean, I think that we need to logically go through and see what happens there and how we move things from where they are to where they are. But the basic concept you're trying to get here of, I think it was Ecker who suggested it, and maybe, you know, it's the passive aggressive, but we're trying to get the best of both of these things. Of knowing that I mean, right now we can't know when we're completely done and have the early nomination type thing, right? And that's what we really want. I think that we can do that in a backwards compatible way that works with existing systems. I just think we need to go through it and figure it out.
Okay. I mean, this is our proposal on how it could be done, and I think there might be ways to, you know, tweak this as well. But I think this is a better starting point than starting from aggressive, because the change is, you know, as you see, it's quite nominal that you have to make to actually get from regular nomination to here.
So, you know, in order to determine what's, I mean, Colin, you may want to stand back up again. In order to determine what the problem is that we don't really have a good sense, because it's so hard to read the specification, we don't actually, and implement it correctly, we don't have a really good sense of how the existing extent implementations work. And so we don't know, for instance, whether you're actually going to be thrown into regular nomination as soon as you produce the ICE options messages. We don't know whether they are going to receive in the environments. And, you know, we don't know when they send with aggressive. So, I mean, I think that, like, you know, Colin, I think and the web browsers are flexible at this point. Like, we're continuing to update them, and so if we decide the browsers to do something new, the web browsers can adapt as long as it's sensible. I mean, I think that's true for Firefox. I'm sure it's true for Chrome too. So, but I mean, but on the other hand, something has to change here because it's not really acceptable, right, Colin? So I guess my point here is, I think to some extent it's on the people who have made the existing equipment to help tell us what would work well with their implementations, so we can try to sort that out. I mean, this is Justin's stab at what he thinks will work best with their equipment. And my guess is that's true too. But if you think that's not true, I think you need to come back and say, this other thing would work better with us, because I think we're happy to listen to that. At least I am.
So, Martin Thompson, when Jonathan mentioned that ICE options was a red herring, I just realized that ICE options as a means of suppressing aggressive nomination doesn't work, because the offerer is the one that actually creates the opportunity for the ICE options to be present anyway. So, you can send the ICE options to the answer?
Somebody agrees to send the answer for triple, so you
Yeah, never mind. But you're right, it was a complete red herring in this context anyway. I really got up to say that I think that the hyper-aggressive, or whatever you want to call it, nomination that was, you know, really use candidate option, I don't think works particularly well because you'd actually have to signal it and agree ahead of time, and I'm not sure that's going to work for all those legacy devices anyway. You always send really use candidate?
Don't call it really use it, call it.
Yeah, I'm done, thanks. Yeah.
Yeah. Right, but I still have to figure out what happens if like that packet gets eaten or something like that. We talked through a bunch of the stuff in the sort of mailing list thread that actually led to this proposal.
To answer Ecker's question a little bit, I mean, I think that what's important to realize is probably many of the ICE implementations were done long before the spec was done. Most people can't understand the spec. Many people think it's the worst spec ever, and no one can read it, right? So what people implemented, you know, the one thing that was consistently implemented is, hey, once I've got connectivity, why don't I send media on it? Which is roughly what Justin's proposal is here, right, when you get to the heart of it. Like, that's widely supported. But once you start talking about options and other corner cases, it gets a little messy. Now, if somebody, you know, what would happen to the existing implementations? They got some new ICE message at the very end that said, hey, we're totally done now. Drop it on the floor, that'd be fine. No.
This is proposing really doing exactly what Colin's saying, like send media as soon as you get a check that completes, and you know, but only send the use candidate stuff to say, hey, yeah, ICE is completed.
I think lots of implementations did that. I think some implementations from some, you know, large UC vendors went and did exactly the opposite. Right.
So I think it would be helpful to figure out what are the failure modes that we're worried about, and we can kind of go through those in detail and try to understand like what mitigations might exist.
Right. So, I mean, the biggest failure mode in my mind would be anything that resulted in having to wait for ICE to fully complete before you could start sending any media. That would be a huge failure mode. Right?
Well, I can comment on that. I mean, we are now making ways to ICE to actually finalize faster, the TA and everything. But then the one implementation I am familiar with, I actually did quite the opposite. So I actually do all the way. I kind of missed the part that we're going to actually even send stuff before. So I guess it depends. But then again, my implementation probably is in the minority.
But your implementation doesn't do aggressive anyway, right?
Exactly.
So I think that the only downside would be that you would any of the media that was sent by the endpoint that's doing this passive aggressive stuff, you just throw on the floor until you complete your regular nomination. And you were already going to do that anyway. Someone starts speaking to the receiver, before ICE is completed, you're going to throw that media away no matter what. So I don't think it's any different than what you have today.
Probably wouldn't be any issue. But then the more important thing regarding this, so what would need to go to ICE-BIS for this?
Oh, so yeah, so for ICE-BIS, basically we're saying just, we take this buried nugget or buried gem on page 69 and kind of make this more prominent and sort of describe how, we see this fast nomination working. And we would then probably keep the aggressive nomination stuff in the text, would say this is just for compatibility with endpoints that are expecting the aggressive nomination, but basically mark it as deprecated, and say that everything should be doing this new thing.
Okay, so don't do, but okay to accept.
Pardon?
Basically, so you don't, as a deprecator, you mean wouldn't do it actively, but if the other endpoint is doing it, behave accordingly.
Right. I mean, we may even be able to kind of find our way out of that as well, if through ICE options or something else, or some other mode where we can work with something else that wants to do aggressive. That not only would you not try to do it, but you wouldn't even have to have any code specifically to do it, even if somebody else on the other side, requested it.
Yeah, I guess what you could do is send ICE option, don't do aggressive.
Yeah.
It and
we could have some pseudo option like that, and that would be one way to get out of it. There may be simpler and less ad hoc ways. But yeah, I mean, my ideal would be, aggressive nomination is deprecated, we get all the benefits in this new thing, and the code that then implements ICE-BIS only has to carry around this algorithm.
Okay, I think that would be doable kind of in the scope of ICE-BIS. So basically clarify the existing thing and then mention about how you can avoid doing aggressive.
Okay. So I guess I'm still trying to get my head around what Cullen, or Scarlett, I'm still trying to get my head around what Cullen's concern is. So let me see if I can restate it, and then you can tell me if I have it wrong. Is your concern that there are existing implementations which expect to do aggressive and do not support sending media prior to candidate nomination, or receiving media prior to candidate nomination, or sending, I guess, that if we change this mode, will then effectively be thrown back into old regular nomination, which is slow? Is that your concern? Okay. So first, I'd really like to know if there are any of those implementations. So it seems like really we need someone needs to come forward and say they have implementation like that. If there are implementations like that, I'm tempted to go the way Justin was just suggesting, namely you can't be ICE options because this stupid rule on ICE options would throw you back into regular nomination. But we can invent some new indicator that was I want to do ICE passive aggressive mode, and if you didn't get acknowledgement on that, you simply wouldn't do this. And that would be safe because it wouldn't, we can't do ICE passive aggressive in an ICE option because that throws you back into regular, which is the source of the problem. But we can have ICE, optional options, which says do passive aggressive mode. And that seems like it would not have the problem you're suggesting because anyone who was one of these old guys would continue to do aggressive. Anyone who's one of the new guys would do this thing. It's not quite as not quite as good as what Justin would hope for, but that might be the best thread in the needle. But I really like to see some evidence of someone who has this problem first.
John, one thing we should remember, I'm not sure how much all this needs to be negotiated, because all of this is entirely, aggressive versus regular nomination is entirely a unilateral decision by the controlling endpoint. The controlled endpoint doesn't have any control, it has to deal with what the other side is doing. So the question we actually have to resolve is, are there existing implementations which were tuned expecting their peers to be doing aggressive, and thus, before they get a used candidate, will drop received media on the floor. And that means that, and that's still no worse than if they happen to be talking. What? Yeah, well, no. I guess that's still, if that's the case, they're no worse than if they happen to be talking to a peer that was doing regular. If a 50 to 45 peer that's doing regular, they're going to have the same slow behavior, right? And I understand they're attuned for aggressive, and they'd rather be doing, they want fast connectivity, but if you're the control input, you can't help that. You can't, so the important question is are there cases where those things will drop received media on the floor? Because, if the issue is just that, they fall back to their peer was doing regular, they already had that behavior. I'm sure they'd rather get fast convergence, but if you're a control input, you can't help that.
I think the actual thing is like anything that was made to do aggressive nomination, but was written to be so careful that said, wait, I'm not doing aggressive nomination. I must throw any media that comes in before my regular nomination is. Right. Well, yeah. So they would have to be written to be like overly sort of cautious, I think, in order to fall into this trap.
Well, I think that the people that implemented both aggressive and normal mode would have probably, if we look at those implementations, they were mostly did exactly that because that was what they thought the difference between the two was. But I think that what I'm suggesting is a backwards compatible mode as a way of backing this in is just add a done message to the end of to aggressive mode and not do anything else. You're done.
It doesn't work though because you don't have the ability to do dynamic control during aggressive nomination. Unless we go and sort of reinvent that, under the sort of framework of aggressive nomination, but then we don't get the sort of simplification parameters. I think this solution has a lot of other nice properties to it that.
Aggressive always allowed dynamic control, right?
No, aggressive never has had dynamic control. That's one of the reasons I'm standing up here. If you look at the text, that the only control over which selected pairs use is the priority tuple in aggressive nomination. And that's because the controlled side has no way of finding out which pair did you actually end up using.
So that would be the part that I would push on to extend would be the sending the message to say what you want to use. Yeah.
So I would invite you to make a proposal. I think there's a lot of stuff to work through.
Ari Keränen, one clarification on the implementation I've been discussing. So that's not anything you will see in the wild. That was a research prototype, but just more as an example of one way how someone could interpret the draft. But I guess once we now clarify that this issue, they actually may receive media early, those kind of stacks shouldn't be that big an issue.
Emil, so on the point of implementations, I think that there are actually many implementations that, so first of all, before WebRTC came along, ICE was really an inter-application thing. Applications were generally communicating with themselves. There wasn't a lot of interoperability anyway. And I think most of the snippets shown this is exactly true. So yes. So most of the snippets showed that very, very clearly. And when WebRTC came along, people started basically being compatible with WebRTC implementations. And those are still very much in progress. And the people who interoperate with them are sort of tweaking their stacks every day anyway. So the implementations that I have seen do regular nomination, for example, and then they added aggressive nomination just to be compatible, sort of, but they would still wait till they would still wait as a little bit as in the case of regular nomination until they start giving media to the application. So I really think we're overstating the concerns here. And I think that this is a very painless approach. It also has the advantage of simplifying the specification. And I think that if we take another approach, like really do a really use counting or something like that, we would complicate things without actually gaining anything because, because there isn't that much interoperability, like fixed interoperability in terms of ICE. We're not talking about SIP here, we're talking about ICE, right? So
it's just not true that they don't widely interoperate. People don't take their stuff to SIP it once it's working, right? They stop going. There's no business value to taking a working product to SIP it for the most part. So you said that it isn't interoperable. It's not true. So that's just, again, if you go to like X10 is a company that's probably does ICE interoperability with over 50 other products, right? So I just, this is not the case. I welcome you to bring any concrete data suggesting that there isn't widespread interoperability. I can bring, 50 people, different vendors that list their stuff works together.
Okay, so I'll let propose a way forward here. Eric, Dan Burnett. I'm just going to say the name of whoever promised to say my name. So I'll propose a way forward here. My sense, and I think the sense of most of the people who've implemented ICE, is that if this can be made to work, this is a better solution than a done flag. And I think it's clear this can be made to work if we have a negotiation parameter in the SDP that doesn't otherwise throw you into regular nomination, i.e., A equals ICE passive aggressive, or A equals ICE 2, or whatever, right? So, and for me at least, the question of that indicator is needed is essentially solely a question of how the installed base reacts to this behavior if we do it now. So what I suggest is that we adopt this behavior with an open issue to determine whether or not there in fact is an install base that is offended by it. And if it is, then we resolve that open issue by putting an indicator in the SDP. And if there's not, then we do not put an indicator in the SDP. Otherwise, until like next week, we determine whether we need an indicator. Does that give anybody heartburn? Well, why?
Because you've asked me to send a proposal of another way to accomplish your goals that meets your goals and is backwards compatible. I'd like more than 30 seconds to do that.
Cullen, I'm willing to listen to that, but I mean, this issue's been known about for basically 9 months, and this exact done suggestion has been litigated a number of times. So, I mean, yeah, it's okay. And I don't understand. Like, frankly, I'm a little confused about what would be the virtues of that design.
I'd like just a chance to go and read this. No one in this room seems to be able to speak to the fact of whether this design would work well or poorly with a widespread existing stuff. Okay, so I think it would be worthwhile spending a little bit of time looking at some of that stuff and trying to figure out whether this was a great design or whether we might propose a different design. Right? That's all I've said.
Well, I think Eric... What's the termination condition? Okay, sorry, go ahead.
Well, I was going to say is I think what Eric's proposed way forward sort of afforded for that. That, we could sort of say, let's do this, have a flag to control whether it's fobbed on or off, and, that would allow us to, based on the results of the investigations that we end up doing with installed base, decide what the default for that flag should be. I mean, I think that, between this and like extending aggressive nomination, like this will always have the sort of advantage of being like less complicated because won't be modal.
Let me be very clear. If we're putting this in the document and we've decided this is the right way to go, I'm not going to bother to go spend time and energy trying to argue about it. It's just a waste of time. So we could decide that now. I'm okay with that, and I won't bother doing anything. But if we want me to go and bother to do something and try and look at this, I'm glad to do that too. I don't care at this point. Okay? But I'm not, the game of, we'll put this into the document and then you can go and try and argue it out. That's not what I said. Not doing it.
No, wait. To be clear, that is not what I said. What I said was, put this in document and the open issue is whether it be an option to indicate it, negotiate it. If you think this is the wrong, so I'm trying to understand what your concerns are. If you think this is the wrong technical direction for a reason other than the interop issue, then we should debate that. If you think this is a direction for the interop issue, I think my proposal resolves that, and I'd like to understand why it doesn't. And so the only reason why it'd be useful to have a separate proposal for a done flag would be if you think this is the wrong technical direction for a reason other than the interop issue, or if my proposal for the interop doesn't resolve it. So I'm trying to understand what your objection is, so I understand what we should be waiting for.
What we're trying to get to, I agree with. Okay, I think that's a desirable outcome to be able to have that type of functionality. I don't have a proposal, like if we had no existing equipment, like, we dump most of ICE, right? It'd be much simpler. We do something like this, right? What I'm saying is, given we already have stuff out there, what's the best way to change it such that we get a fairly good backwards behavior way with stuff and get this? And I know I don't think that the option tag really is the answer to that. Because no one reads them.
The point of the option tag will be that we won't do this unless the other side agrees. So my point is, you would have whatever the ordinary behavior would be, which would be hopefully aggressive mode. If the option tag negotiation didn't happen, this is a new option whose job it is to allow you to do this mode Justin is proposing.
I'm trying to avoid us having, adding 3 modes that we negotiate between them, of which, existing equipment uses 2 of the old modes and browsers implement the 1 new mode, and effectively we have even a worse interoperability situation.
I'm certainly well, if you want to produce it. Okay, well, I guess from my perspective, if you want to produce a proposal that will do that does a done flag instead of doing this, I'm willing to wait a limited amount of time and give it a fair hearing.
I'm not proposing the done flag. I said look at it and produce a proposal, not one the done flag or whatever. Just try and figure out what to do.
Okay, right. If you want to produce a proposal, I'm willing to wait a limited amount of time and I think we'll attempt to give it a fair hearing. I'm not fixated on this. I want to be done too. I guess, and I don't know how other people feel. I mean, I'm certainly as long as we resolve this by the next IETF, or at least are prepared to resolve it the next IETF. I'm prepared to wait that long. If you can't get it done by then, I think it's unreasonable to wait any longer. So I don't know. For me, that's fine. I don't know what other people think.
Yeah, I mean, I'm fine with.
So from the chairs here, first of all, time check. We have 10:52, and Justin, you are already into your next time slot. So I don't know. You can use your time whichever way you want. Do you want to continue this on? Do you have more slides on this as well?
Yeah, I like to continue on here. The next slides are about continuous nominations. I'd like to actually get to that. I think what we should do here is sort of, try to sort of iterate this particular proposal, understand how we might sort of deal with any issues. Not necessarily say this is the way we're going to do it, but basically, try to flesh out any other things to the satisfaction of all here. If any other proposals want to be put forward too, we can then evaluate these, hopefully with the expectation of getting to a fully baked and proposal for Prague that everybody can get behind.
Yeah, Martin Thompson, I propose that we set a limit on the alternative design stuff of halfway between now and Prague.
Yeah, that sounds good.
And if nothing arrives other than this before then, we will proceed in this direction and deal with the open issue that Eka just identified. That's my proposal.
Are there any volunteers to help me with just finding out the best way to kind of polish this up, or this particular direction? Okay, thanks. Okay.
And just checking, Colin, Colin, you seem to be the one that has, some concerns here. Does that way forward work for you?
Yeah, sure.
Okay.
Okay, next slide. All right, so that's for aggressive nomination, and we've talked about that. So there are some other cases, though, that, regular and aggressive nomination both end. And that's, good in sort of getting to a final state in some cases, but it's not always ideal because you may actually want to change what pair you're actually using, and in order to do that, you actually have to do a nice restart. So I'm introducing this concept called a continuous nomination, which allows you to switch your selected pair at any time without a nice restart or any information being exchanged across the signaling path. You can also, if you discover new candidates, either from new turn servers or a new interface that comes up, you can actually then trickle those to the other side at any time without a nice restart. And if you come up with a couple scenarios where this is actually quite useful, if you're in a case where you're on 3G, but you also have flaky Wi-Fi, you can dynamically, based on kind of your RTT or your packet loss statistics, switch the selected pair between your Wi-Fi or 3G interface at any point in time. This seems quite valuable in many mobile scenarios. If you actually get it all to go the way to full mobility, where you actually walk all the way out the door, your Wi-Fi disappears, your 3G comes up. In the cases where you don't have multiple stacks available at the same time, you can then trickle the candidates on the new 3G interface and get the ICE coming up on 3G without having to do an ICE restart. There's also Brandon's proposal for doing turn server selection to avoid triangle routing, where when you try to talk to a turn server, you may find out, hey, there's another turn server that you should be using. Problem is you've already done all your candidate allocation and moved well into the ICE process. And so here you could actually trickle a new turn server even after ICE had completed that you found out about, and then do RTT evaluation of, okay, here's my current RTT, here's the new possible RTT on this new turn server path, and then dynamically choose between them. Next slide. So the way this would work would be you would have an explicit option to kind of opt into this, because this is like fairly distinct, that ICE never ends. You always have to be able to deal with pair switching, that kind of stuff, and you're going to be expected to keep pairs alive. Now the controlling side has, as its name implies, really the oversight over how this process works. All the pairs will be sort of maintained by default, and then the controlling side will have the ability to actually decide which of these pairs it actually wants to keep and which ones it actually wants to release. And then the actual switch will be done by sending, the media will change over based on the controlling side's choice. It can also send the use candidate flag at any time to say, now this is the path that I actually want to keep using. In many ways, that's very consistent with where we're trying to go with this passive-aggressive nomination stuff. And if you have a case where all of a sudden you have two interfaces going and then one of them all of a sudden disappears, you can just move your media over, start sending it over the new path with no signaling, and if your signaling path is being knocked out by this this interface cutover, you don't have any issues waiting that signaling to come back up before you can tell the other side that you're going to switch. You can just switch that media immediately. I'm going to talk about open issues on the next slide, so if you have your concerns about this,
I just wanted to check where, Emil, I just wanted to check where, basically, I think one of the most important things that would be very valuable to get out of this meeting is about when you release invalid candidates. Is that going to be in the open issue slide?
Yeah, I'm going to cover that next slide.
Varun Singh, just want to make sure that this works with multipath RTP, which is like a new proposal, also in working group draft and UVT core, and don't want this to like break things like scheduling, which might happen at the RTP layer just because the ICE decides to do things differently.
Yeah, I mean, we should make sure these things work together. I did look over the MPRTP draft as well as like some of the other drafts around ICE mobility and turn server selection, in coming up with this proposal. So at least a couple months ago, they seemed like they were not in conflict. This doesn't really talk about the idea of having multiple selected pairs, being able to send media over multiple paths, which MPRTP would require. However, I think that once you have multiple pairs, you're already well down the way of being able to do MPRTP. And like I said, when I reviewed it the last time, I think they were consistent. I invite you to take a look at this and see if there are any issues that you see. Right.
Multipath also allows you to do failover, so there might be two things that are being solved at two different layers. So I'll have a look at this. I'll take that as an action point.
So does MPRTP explicitly consider running on top of ICE, or is it also being set up for being able to run like in an ICE-free context?
Initially both. So
okay.
So that's why.
Chris, a couple of questions, clarification, maybe they will be. I assume for the first one is that if a pair goes away, and you switches to another pair. I guess it's an implementation issue whether you're going to keep checking if the old pair comes back. As far as I remember, the draft doesn't really say anything that either you should or should not do that. I guess you can do that because, it basically would be adding a new candidate once it comes back.
Well, it depends on what you mean by goes away, whether the interface actually goes away or whether it just it falls off the valid list.
Yeah, your keep alives or whatever, they don't work anymore. Maybe the NAT binding goes away, maybe the interface goes away, maybe, the Wi-Fi goes away, whatever. For some reason you can't use this candidate, so you candidate pair, so you switch to another one.
Well, so I think there's two different cases. There's the interface going away, in which case like it's dead, and
No, interface. That was wrong wording, but
Sure.
Wi-Fi, for example, goes away.
Right. So I mean, there are definitely cases where a pair doesn't work, maybe because where the peer is at a certain point in time, but later the peer kind of transitions to a new network, and suddenly the candidate you had on your side that wasn't working before now works. And so there's definitely reason to believe that certain things should be tested even if they're not currently working, because they might start to work. That's not always the case, obviously.
The other question was that I assume either side can, of course, if both sides support this and use this, either side can at any point switch.
No, the controlling side is the only person.
It's only controlling. Okay.
Yeah, because otherwise, how would you converge, right?
That was okay.
Yeah, and so the controlling sort of gives us a nice way to kind of get out of that.
So, Martin Thompson, I was under the impression that you were using the sort of continuous consent style of interaction for maintaining the candidate, the secondary or backup candidate pairs.
That's right.
And if one of those goes away and you lose checks to the point that consent expires, the 30-second timer that we have, I think we should regard that as gone, and the candidates should be shelved, because if you haven't had continuous checking on that for that time, all of the NAT bindings are going to go away, and you're left in an
I talk about that on the next slide as to what causes things to die.
Yeah, transient failures are fine. I mean, it's still technically valid. I mean, you just lost a couple of checks.
Right, but I think you're definitely if it's been down for 30 seconds, the chance that it's going to come back, it's probably time to call the patient. So I don't think it's going to come back. Okay, next slide. Okay, so the question is how by default all the pairs are kept alive, and so the question is how do they actually get released? And there's a couple different ways we can do this. One is that the controlling side, as long as it sends these continuing consent checks over the pairs, that serves enough to keep them warm. And as long as it does that on the continuing consent intervals, everything is kept alive, and the control side has to keep them around, or these pairs can stay valid as long as the controlling side is continuing to send these continuing consent checks. The second thing you could do is that you could have some sort of lifetime attribute like with turn, where you sort of say, hey, I'm not going to keep pinging this thing all the time, but I'm going to say I don't want you to get rid of this for this period of time. And the other thing is we could just sort of say, well, I'm going to ping these, but the way I'm going to tell you that to get rid of them is by sending you an explicit, lifetime equals 0 or some sort of attribute saying I'm not going to use this anymore. So there are a couple different ways that we could deal with this.
Emil, so I'd suggest we do option 1 and 3, because option 2 seems a little bit too convoluted. I know that I might need that for the next 5 seconds, but then I'll probably not need it. That's too much hassle. And what will be the use case that actually requires that? What I see is you basically keep it on for as long as you need it, and when you stop needing it, you just terminate it. And I don't really see the point of doing option 2.
So the reason why option B might be used is if we think there's some cases where, for power reasons, we don't want to keep sending pings, but we don't need to keep any pinholes or anything else like that open. So we send one check which says keep this around for the next 5 minutes, but then we don't actually send continuing things on a regular basis. Now, how that interacts with continuing consent, may be problematic.
So the point that I'm trying to make is, how do you come up with that value of 5 minutes? What sort of an oracle are you?
Well, I mean, there are sort of timeouts for turn servers and stuff like that. The bindings won't expire, and they're quite the same way. Those, you won't.
Well, for the servers, you have different considerations, right? Because here you're basically I might move in the next 5 minutes because I've been feeling my user a little bit jittery right now, so I expect him to move. So please keep that candidate alive. And I mean, and it's sort of overloading. So you have the so if something goes wrong, option 1 is going to trigger, and the candidate.
I mean, I think option 1 is the simplest. I mean, it just probably has the highest power cost. It's not clear that option 2 necessarily can always save power, because I think you may end up having to be more conservative in that, sending pings more often to keep pinholes, because you don't even know like host candidates might still need pinholes because of just firewall policy and that sort of thing. So you may need to keep a lot of these things alive just to keep firewall pinholes open.
But you can do it with option 3 as well.
Well, that's for explicit like termination, yes.
Yeah, sure. But so until you explicitly terminate, you get your pinholes alive and everything. So.
Sure. But I mean,
to me, it's just a little bit extra complexity that doesn't actually bring you.
I see. Right. Sure.
Yeah. So Martin Thompson, I think I like the simplicity of don't use candidate or something equivalent to that. Timing is. I don't want more timers. We have enough already.
Okay. All right, so one of the other questions that came up was on the controlled side, how much discretion does it have in terms of dropping candidates? For example, if it has both like Wi-Fi and 3G active, and keeping both radios powered is definitely a significant power consumer, and if it's able to get things working on Wi-Fi, is it really necessary to keep the 3G interface open? And so I think this is a very good question. I think control side probably will want to be able to drop only certain candidates for power reasons. And I think the control side should have that discretion. We need to figure out how that interacts with the controlling side's wishes, but I think that the controlling side decides which pairs to keep, and the controlled side may choose to drop individual candidates.
Yeah, so Martin Thompson, I think this is probably okay. We might like to consider whether the controlled side can unilaterally send the same sort of indication on one of its connectivity check responses, just to make sure that, or something along those lines. I'm not sure what the correct behaviour is there, but I think we probably need to have something so that someone can just simply opt out, because I don't want to be on the other end of a stream of connectivity checks that I can't stop.
Sure.
And there's also the fact that if the control site doesn't want to communicate, it will stop to communicate. So, or stand error or everything. So,
yes.
So, I suppose the question is not really should we allow the control site to do that, because it can. It's about agreeing what is the best way for the control site to indicate that.
Right. Well, it's a protocol, so like the controlling side could definitely express its wishes to where the controlled side get to do things, but like it would be nice if these things A, converged, and B, didn't waste stuff on the controlled side unnecessarily.
Cullen, I was going to phrase, I think, roughly the same thing as a requirement. I think we should have as a requirement figuring this out, that either side can cause checks that are using up power it doesn't want to use to end, not just one side.
Yep.
And it seems like there's lots of ways to solve that.
Sorry. Justin, time check here.
Okay, this is the last slide, so I will just go through this last bullet here.
Okay.
Then I have an issue as well.
You got 2 minutes.
Okay. Okay, so the other question is how often do we send these pings on the backup pairs? It seems like we need to send it as often as needed for continuing consent, which is like every 15 seconds, which basically means that the radio is really almost never going to sleep, if at all. I think that's kind of unavoidable because you probably need to send it at least every 30 seconds for, keep pinholes open. We may decide that we want to try to relax some of the continuing consent timers for backup pairs, to be more power efficient, but I think we'll deal with that when we're further down the implementation path.
Emil, so on this specific point, and then I have others, but could we just align that with the consent checks and just use the same thing?
I think that probably what we'll end up doing is just making the consent checks probably match what we think is the right sort of trade-off between pinholes and power.
Mm-hmm. The one thing that I consider very important here is to agree what we're doing with candidates that didn't work during the initial negotiation. The reason this matters is because, well, that's different, right? Because basically when ICE completes, you're going to have a number of valid pairs, and you may want to keep them all unless you explicitly decide to terminate some of them. And those that you keep, you're going to be switching in between. Exactly, so those that you decided not to keep alive as pairs, and those that didn't work as candidates at all, what do we do with them? And that's very important, because if we decide there's like this assumption in the draft that they're going to be kept alive forever, I'm not necessarily very strongly opposed to this, although it makes me feel uneasy. But the implication that it's going to have is what happens during trickling. When you learn new candidates, what do you pair them with on the remote side? Can you rely on these candidates to still be alive there? Or do they need to be trickled back to you with potentially different port numbers and all that sort of stuff? So basically the question I'm asking is...
So Emil, can I interrupt you?
No,
Sorry.
I'm on a roll here.
Yeah, I know. I'm afraid we're going to have to cut the technical discussion short at this point and focus on next steps. And if you could do that really quickly, because we are way behind at this point.
Right. So, I mean, that's all good feedback. I guess what I'd like to find out now is, like, we talked about the continuous nomination stuff. You know, is there sufficient support that this is on the right track, that we should adopt this as a working group item?
Well, we had a whole bunch of discussion. I guess in general, at least what I got, we're on the right track. But working group item, I think it's a whole lot of open issues and things to discuss. So we're not quite there yet.
Okay.
But I mean, in general, it seems that something like this is useful, but there's a lot of details we need to figure out. So it would be early to call for adoption yet now.
Okay. So what I was going to do is then separate this work into the passive-aggressive stuff that will then sort of flow into ICE-BIS, and then this is continuous nomination that will be its own track.
That would be right way forward.
All right.
Okay, thanks. So yeah, we had another set too, but since we are running low on time, let's have Paul-Erik now on the dual stack fairness. And if we have time after, if Paul-Erik finishes early, we're going to have the other one.
Yeah, Paul, if you can focus on basically the issues that you need feedback on. We don't need to go through changes and stuff like that.
Well, just next slide. The most important thing is that in the 02 draft, we added multi-home support, next draft. This is the old formula, which is there. Next one. This is actually the Schrödinger wave transform. Next one. So we added a little stuff to the end that would enable a multi-home support for this. So you could actually mark the interface as reliable or unreliable and actually prioritize the reliable interfaces when you're doing this in connectivity checks. Next slide. So keep in mind, the formula does not alter the type preference, host, reflexive, or relay. For the multi-home stuff, an interface is either reliable or unreliable. There's nothing in between there. If it's reliable, you could add a value to it or a preference. That's up to you to decide.
Mike, please.
Microphone.
Just a
Name,
question
please.
for clarification, Martin Thompson. What makes you suggested that things that are reliable or unreliable will be based on some unspecified heuristic that someone's going to apply. What's the property that we're looking to achieve out of that?
Well, for basic implementation, I would mark everything as reliable and try to just give it some sort of preference. For if there's a known interface that you know that never succeeded any connectivity checks, I would mark it as reliable for the unreliable for the next call.
Oh, so you're basically saying that you can put certain interfaces on a shit list.
Exactly.
All right.
Okay. Heuristics, or
Okay,
if you know that Tornado tunnels doesn't work or whatever.
So Paul, correct me if I'm wrong, but this particular feature was now introduced because last time we discussed that some IPv6 tunnel interfaces, for example, can be problematic. I would somehow be able to down prioritize those. So this is the suggestion to fix that issue.
Yeah, somebody, there was some discussion that some certain IPv6 addresses, like Tornado addresses, didn't work reliably, so they wanted a way to fix that. It was already supported in the old draft. But we decided to go, like since the dual stack is really just specific case of multi-homed, then I thought, yeah, well, just try to solve the multi-homed things as well.
Jumping ahead in your slides, because I was looking at your slide deck, it looked like you're saying that you've got reliable and unreliable, then a priority among the unreliable. I mean, I'm not sure why you don't just have a global priority, because I mean, my Ethernet and my Wi-Fi both work, but I would prefer to use my wired Ethernet if it's working. So I mean, I think I want to have priorities there too, and ICE has always defined notion of priorities among interfaces. So I think that this might be able to be simplified that the shit list is just the end of the interface priority list rather than having the flag plus the priority. Yeah.
Small bit. He's just computing the global priority using information.
Yeah, I know, but it sounded like I mean, at least reading the slides, not that I've read the draft, it looked like you had I mean, I don't know if you want to flip forward in the slides just because I was reading on my laptop. Oh, no, it was backwards. Never mind. One back? Oh, yeah. So you said interface priority, reliable interfaces all set this interface priority to 0. And I mean, I don't think that makes sense. I mean, because it seems to me like I said, my Wi-Fi is reliable, but it still should be lower priority than my wired Ethernet. So.
That just means that all your 200 IPv6 addresses assigned to that unreliable interface would always be at the bottom, not intermingled.
Oh, I see. So you're saying that on unreliable, all IPv6 goes to the end for unreliable. It's not intermingled at all.
If it's marked unreliable, IPv4, IPv6, everything is at the bottom.
Okay.
Otherwise, it's kind of intermingled.
Okay.
I don't know. Yeah. But yeah.
So you wouldn't be able to push something that was, say, a host candidate below server reflexive as a result of that, would you? As local preference only. So
yeah.
I thought you were describing something new, but it's not really. It's just
no, it's nothing new. It's
adjust your priority accordingly, exactly the way that Jonathan describes. Yeah. Okay.
Exactly. It's not mandatory to implement that. Like you could choose the local preference any way you want. We just wanted to give implementers some hints on how to do that.
Yeah. I think allowed values can be anywhere between 0 and 1.
Well, it seems like the most helpful implementer guidance you could give is advice about how you might use what happened on previous calls to set these values on your next call, or whatever it is you're going to do with them that way.
There's wording in the draft that says that you could either choose static values or dynamic values or whatever you learned. Okay, next slide. And the one after that. There is also a priority formula in ICE TCP that needs to be kind of meshed into this, so we have one formula that can works for everything. Okay, next. So the real question is, should we keep the multi-home support, or should we just go back and focus on the dual stack?
Comments, please.
Jonathan Lennox. I mean, I think this is all targeted as informational implementer guidance at this point, right? Yeah, I think that dual stack exists and is becoming more common because all our phones have, cellular and Wi-Fi. So I think having implementer guidance that doesn't actually give implementers the guidance in the real world is not helpful. So I'd say keep the multi-home support. I'd say describe the problems implementers are actually going to be facing, not half of it, and let them figure out the other half.
So Martin Thompson, my only complaint with this draft, as I've gotten up here at numerous meetings to say, is that it is highly prescriptive and doesn't need to be quite so much. you have a formula. I don't want to see the formula. I just want to say that if interfaces were shown to be in the past unreliable or not successful, apply a lower priority to them. And apply priorities such that V4 and V6 addresses are given an equal or relatively equal chance of success. Not those sorts of things, rather than just going, hey, do this particular... Well, yeah, I mean, experience shows that those are going to work against each other. But experience shows that if you do the first one, you end up with the second one anyway, because if you put the V4s at the bottom in the first call and the V6s all at the top, as ICE actually mandates that you do, what happens is if you have a number of calls, what happens is all the V4s go to the top and the V6s go to the bottom. So this is simply just guidance, and I would like to keep it guidance rather than saying that you've got some formula with the max of this divided by this times some number. You're saying that the values for this reliability indicator can be 0 and 1. Well, that's prescriptive because now you've effectively excluded 0.5 and all the other options, right? So I don't want something so nailed down. I just want this to say, this happens, these are the considerations, you may do these things in order to deal with these sorts of problems, and that has the following consequences, and just sort of leave it at that. Now, that just means removing some formulas, I think, because most of your text is actually exactly that, the useful stuff. But I think that implementers will be distracted by seeing a formula there and go, well, the IETF has said that this formula needs to be implemented, and therefore they will implement it and miss a lot of the nuance that you're trying to get at. So I would strongly suggest striking, and maybe you can put the Heisenberg formula in there instead and see how people go, right? We've got Unicode coming, haven't we?
I agree. I was asked to be more specific at some point, and I added a formula after that. Happy to remove it.
Is the person who made that request in the room?
Okay, again, as an individual, I think I was one of the persons who suggested that, and I think the idea was that you want to have roughly similar things on both endpoints on the candidate priorities, otherwise things go funny. We'll have to go back to details, what the discussions we had back then, but anyway, so you're suggesting removing the formula completely and just having general down priorities, put this priority higher.
The only funny business that I'm aware of that happens, because priorities are signaled and we all have a formula that
candidate pairs needs to be
adhere to.
Yeah.
The only funny business that goes on is if you've got legacy devices that are actually strictly adhering to 5245 and putting V6 first, they just don't connect fast enough.
Should still work.
It just works. It continues to work. It just, you do a few failures when your V6 tunnel addresses are being checked.
Yeah, the core thing is that playing with the local priority, that should work. Doesn't cause you any harm.
Right. This is completely harmless.
Yeah.
You can do whatever you want to that local priority, and things will ultimately connect, unless you do something silly like put in too many candidates and overflow the 100. which is actually, with multi-homed and dual stack, is an imminent threat. I did some calculations at one point, and it's kind of scary. We're getting close to the limit.
So that's the main purpose, is saying that playing with the local preference, that's harmless, and giving some advice on how to actually set that with to achieve fairness with IPv4 and IPv6.
Okay, so we are running low on time, and to remind you, we do have a milestone for this work. Right now we don't have a document adopted for that, because last time the concern was that this unreliability of certain kind of candidates needs to be addressed. So now we have a document that addresses the issue, and at least so far we haven't had other documents which would be matching the milestone that we have. So we would like to take another call for adoption for this document. Of course, the details, yeah, those needs to be still figured out. But this is not the last call, this is call for adoption for a document for a milestone. So I would like to take two hums. First hum will be if you would be in supporting for adopting this document, and the second one would be if you think we should not adopt this document.
Do you think a hum is not going to be swallowed by this room?
Sorry? Well, actually, yeah, could be an issue. Show of hands.
I can turn away. And
Okay, we are actually in a massive room. Maybe I don't hear you guys, so let's take a show of hands, probably easier. So we'll take two shows of hands. First will be if you think we should adopt this document for the milestone that we have, and the second one will be that we should not adopt this document. So if you think we should adopt this document for the milestone that we have for the dual stack fairness, please raise your hand now. Yeah, okay, 15 plus hands. So let's say a big fraction of the room, of more than 15 hands. And if you think we should not adopt this document for the milestone, please raise your hand now. Okay, I see no hands in the room. So we had vast majority for adopting this and no one against, but of course we still have to take this to the list. But that's for the note takers. Okay, thanks, Paul-Erik. We have 3 minutes, Justin, if you want to use that for your second presentation. All righty.
Okay, let's get going. ICE and DTLS. So the questions are, what is an ICE virtual connection? What do the RFCs say about using DTLS with ICE? And how do we re-handshake DTLS? Next slide. All right, so 245 says use an ICE component. And it's not necessarily fully clear from the definition, but I think when we talk about a virtual connection, we're talking about an ICE component. It's the best handle for this that we have. Not a selected pair, not a media stream. Next slide. All right, so 5763 is very clear on how DTLS interacts with ICE. This basically tells you everything you need to know. Bernard pointed this out in the list yesterday. This should avoid much doubt. Next slide. 5764 doesn't talk about ICE, and this is where some confusion came from. We should basically direct anyone who points at 5764 back to 5763 and say, just look at that. Next. I'm actually working with Harold to get this text into the transports document, on at least in RTC Web. This can be confusion-free. Next. Okay, so how do we do a new DTLS handshake? So TLS 1.3 says no handshaking in the TLS protocol. This is also being discouraged for earlier versions. We don't have any way in SDP to say, hey, do a new handshake for an existing connection. 5763 explicitly prohibits the A equals connection new attribute. I think we shouldn't worry about this. There's no clear reason to do this. Next slide. Forking, you can have this sort of situation occur. If you get a new remote UFrag on ICE, you basically throw away your existing state and create a new ICE and DTLS stuff. I think that can work just fine. Next slide. So the real question is like, well, what happens when you get a new fingerprint? And in third-party call control, you might have a new fingerprint signaled, and this would require you to basically do a new DTLS handshake. And so there's been one suggestion that we can do this with what they call invite with replaces, like a SIP thing. In pure connection, or in WebRTC, this would be a new pure connection. This handles that just fine. I think in WebRTC said in a lot of these renegotiation third-party call control cases, we want people to use a new peer connection. It's very consistent with that. If you want to do this in an existing sort of session or peer connection, the way you would have to do this, because there's no demuxing of DTLS, old versus new DTLS connection, is basically throw away your existing DTLS context completely and create something new, basically break before make. So if you got an offer with a new remote fingerprint, you could discard your old DTLS session and do a new DTLS association, create a new one immediately. I'm recommending that, you could do this in, outside of WebRTC, but in WebRTC, I think we should not bother.
So Justin, totally agree. I just want to point out that every case I can think of a third-party call control is going to actually change the UFrags and stuff as well. So it'll be the same as the previous case where it's even easier.
Okay. So this is kind of my attempt to codify, the debate around this issue. Please refer to the low time, but we can take these slides to the minute list, but hopefully this should serve as kind of hopefully our collective wisdom on this topic.
Just a short comment. I mean, we need to discuss it. I'm okay with all this. Can I just? But I think
Did you understand this part?
I think it takes.
It's 11:30.
Okay.
So.
Can it on the list?
Yes.
Justin, anything else you want to say? That's it.
Just any further questions on this, please let's take them to the list. Hopefully we can, put this decision or this behind us.
All right. Thank you all.
Yeah.